to write like your stacking cups activity, okay? And then much like when we did the linear relationships and I gave you a whole bunch of pictures and you wrote like stage number, right? What I want you guys to do, we could go, actually, you know what? You can draw this, we can do this. Stage number 1, number 2, number 3, number 4. Okay, you can space it out in a way that kind of works for you. So I'll fix this. I'm kind of doing this on the fly. Okay, and above each of these stages, I want you to draw the picture that it corresponds with. Okay, and we'll build it on the table back there. Okay, so what this is going to be, what we're going to do here is we're going to stack cups. Okay, so I'm going to go back to the table here. And this is a reminder too, you can have down here, you can set up a table of values too, right? Where we had under X, we would have put stage number, right? And under Y, we're going to put number of cups. Okay, and you're going to keep track of it. So then you're going to go 1, 2, 3, 4 in the table of values. Okay, so I'm going to go back here for a sec, and I'm going to show you something. Okay, and I don't write anything down yet. I'm going to tell you when to start writing. Okay, so we're going to go back here. We're going to stack. This will be like stage 1, right? So we're going to have stage 1 with 1 cup. And then as we move across the stages, you're going to see that the number of cups is obviously going to increase, but it's not, when we do the actual activity, it's not going to increase in a linear way, okay? But the base, you guys tell me if you notice anything with the base, right? That would be the base of stage 2. Okay, so we went from 1 cup to 2 cups, and then the base of stage 3 would have 3 cups, right? And then the base of stage 4, if I can fit it on the table, would have, I don't think it's going to fit, but I'll move it down. Okay, so if we actually look at the bases here, so if I just, without writing anything down yet, if this is the pattern that I was going to build, then in stage 1, we're going to have 1 cup, okay? In stage 2, we're going to have 2 cups. In stage 3, I'm going to have 3 cups, and in stage 4, I'm going to have 4 cups. Well, this looks like, if you guys remember, this is where I'm going to take you. If we wrote on our table as well, and remember, I'm just showing you something, so you guys don't have to actually write this down yet, okay? And it's recorded so you can watch it again too. Remember we talked about first differences, right? And so when we do this, we go, okay, well the difference between 4 and 3 is going to be 1. The difference between 3 and 2, that's this one, is going to be 1. The difference between 2 and 1 is also 1. So these all match. Okay, when the first differences match, we know this pattern is going to be linear in this instance, right? Because it's changing by the same amount each time, right? It's going up by 1, up by 1, up by 1, so it's linear, right? So that's not necessarily interesting from the standpoint of patterning, okay? But we can make it interesting, right? So let's go up to the top here, and you guys can start drawing in now. So I don't know how to draw my cups. I'll draw them as squares, okay? So if I were to come up with a rule for this pattern right now, I could say, okay, well, I'm going to take the stage number, right? It's stage number multiplied by 1. That's the rule. So y equals x, where x is the stage number. Okay, that's a pretty boring pattern, right? Where it starts to get a bit more interesting is where I start to build the cups up, okay? So if I go down here now, I'm going to redo the table, okay? Except this time I'm going to start stacking the cups. Okay, so again, we're going to have stage number for X. We're going to have the number of cups. Okay, so we're going to go down, and then we're just going to create the same stages. So stage 1, you're going to have stage 1 is this one, stage 2 is here, stage 3 is here, and stage 4, okay? So stage 1, 2, 3, and 4. So our question is, how many cups are going to be in each of these stages as I start to stack? Okay, well, in stage 1 there, we still are only going to have 1 cup. Okay? Now, if I go back over here and I start stacking, and now I'm going to have 3 cups in stage 2. Okay? And then I'm going to keep going. So you might think, okay, well, if this was a linear pattern, you might be able to say, okay, well, I'm going to go, okay, increase by 2. So then I'm going to increase by 2, and you might expect to see 5 there, and then increase by 2. Right? That's what we've been spending all of our time doing right now for the first little bit of the course. But that's what you're going to see here. That's not what's going to happen. If I stack these cups in the 3rd stage, there's my 5 cups now, where I still have to keep going. Okay, well now it's not 5 cups in that picture, it's 6. All right, well let's do 4. How many cups are we going to be in the 4th one? So we have 4 in the bottom row, okay? Plus 3 is going to be 7. Plus 2 is going to be 9, and then plus 1 is going to be 10. Okay, so it's at this point now that we're able to try and figure out what's going on here. Well, I don't really think this is going to increase linearly, right? Which we already showed. So we're going to actually prove it, though, that it isn't increasing in a linear way using the same method that we discussed before. Except this time you're going to notice something interesting. Okay, so when I go from stage 1 to stage 2, I get an increase in the cups by 2. Okay? Because I'm going from 1 to 3. To get from the next one, stage 2 to 3, I go from 3 to 6, which is a difference of 3. Okay? Then to get from stage 3 to 4, I have 6 cups, and then I go to 10. Well, that's 4, right? So I've increased by 2, increased by 3, increased by 4. The problem with this is now, like above, the bases, so the bottoms, increase in a linear way, right? I'm increasing, adding 1, adding 1, adding 1. The problem is the total number of cups is not increasing in a linear way, right? And we can see that if we look at the first differences, right? When I map out just the bottom row, first differences match. Okay? But down here, they don't match. It's when they don't match that you're able to say not linear. Okay? Now the catch here is though, well, if it's not linear, then what is it? Right? You guys don't know yet. That's what we're working towards, right? But something interesting happens if we just do the same pattern again. But this time we're going to look at what's called second differences. Okay, when I look at the second differences, if I do this thing again, the difference between 2 and 3 is 1, and the difference between 3 and 4 is also 1. Well, conveniently, these match. So that must mean something. What it means is that it doesn't behave in a linear way, but it does behave in a different way that we can actually model and map, right? This, as an introduction, is what we call, or this proves, at the very least, it proves that this pattern is quadratic. Okay? The word quadratic, you don't really necessarily have any context as to what it is at the moment. But if I were to go plot these points, which we can do in a second, all right, so if I open up Desmos here, well, I'll show you. We're going to do a whole bunch of this today, okay? So you don't necessarily have any context as what quadratic means yet, okay? But this is how you prove every single time. If I ask you to prove if a relationship or a series of data points is linear or not, this is how you prove it. You run through these steps and you say, okay, well, if the first differences are the same, like they are if we were mapping just the base, like if the question asked, how is the base growing? Well, the base is growing linearly. And that's true because I can see it here in the first differences because they match. Okay? But if I ask you, how is the total number of cups changing? Is it linear or not? You're going to do the same thing, but what you're going to find this time is that the number of cups and the first differences are not the same. Right? Or they're not increasing by the same amount every time we change from one stage to the next. So then you know it's not linear anymore. But you can confirm that by doing the second differences. If the second differences match, then you know it's quadratic. Okay? So that's that. I'm going to stop the recording there, okay? And then we're going to try something else. So hopefully this is kind of like a cool introduction to what it is we're going to be spending a whole bunch of time on. Probably the same amount of time as we spent on linear, okay? If not more. Okay, so this is a big part of the course. Okay, this is kind of an introduction as to like how are things changing if it's not linear. Okay, so we're going to show you how that actually looks on a graph too. Okay.